CIET NCERT presents audiobook Kaushal Bodh, textbook of vocational education for grade 8.
Page number 83. Project 4. Home Automation. There's a QR code given on right-hand side top of this page. Scan this QR code to find additional resources on this project. Home automation enables you to operate devices at home automatically with the help of technology. In this project, you will learn how to make electronic circuits and write simple programs. As a part of the project, you will be able to first, learn about electronic components and circuits. Second, make simple programs and circuits. Third, select appropriate sensors. Fourth, make an automation system and test it. Figure 4.1. Making things operate automatically using circuits and programs. There is a picture given at the bottom of this page, where some school students are experimenting with different objects and are trying to make circuits and programs. Page number 84. Automation means using technology to control everyday devices automatically. Instead of switching things on and off by hand, automation uses sensors, controllers, and simple computer programs to run these tasks independently. Figure 4.1. Imagine a classroom where all students and teachers leave immediately after the final bell. The lights and fans often remain on because no one remembers to switch them off. This wastes electricity and increases electricity bills. Automation can help in such situations. If the classroom has an automated power system with a motion sensor, the lights will automatically turn off when no motion is detected. This simple change can save energy and reduce costs. Another example of automation is an automatic garden irrigation system, where a moisture sensor is installed in the soil. When the soil becomes too dry, the sensor sends a signal to a water pump. The pump then automatically turns on and waters your plants. Once the soil has enough moisture, the system turns the pump off. This saves you from having to check the garden every day and helps conserve water by watering plants only when needed. Automation is not a new idea. It has always been a part of our world. Nature had already perfected automation before humans started creating machines to automate tasks. Look at the human body. Without thinking about it, your heart beats automatically to pump blood. Your lungs breathe in oxygen and release carbon dioxide. And your stomach digests food after eating. All these functions happen without conscious effort, just like an automated machine. The body uses signals such as nerve impulses and hormones to decide when and how to act, just as an intelligent system uses sensors and controllers. If we look around, nature itself is in automation mode. Like modern automation, nature follows systems that work independently, using signals and patterns. First, sunrise and sunset. The sun rises and sets daily without any action on our part. Second, water cycle. Water evaporates from lakes and oceans, forms clouds, and falls back as rain, following a natural cycle. Page number 85. Third, animal instincts. Birds migrate without Global Positioning System (GPS), generally used by humans. Flowers bloom at the right time, and bees build perfect honeycombs without being taught. From our bodies to the natural world, automation has always existed. Humans have been inspired by automation in nature and made automated things to make life easier. For example, first, the thermostat is a device that automatically adjusts the heating or cooling system, adjusts the temperature in a room, just like our body regulates heat by sweating when we are hot. Second, a motion sensor turns on lights when someone enters in a room, just like the pupils of the eyes adjust to brightness automatically. Humans have always been fascinated by making things that work automatically. Over the centuries, these have evolved from simple devices to complex machines. A journey of automation is shown in Figure 4.2. Figure 4.2. A journey of automation showing transformation from natural tasks into automated systems. There is a picture given in this figure. One side there is a space view of Earth with a timeline which has ancient times, medieval period, industrial revolution, 20th century, modern time, and future as parameters. On the other side, there are automation tasks that have been taking place either naturally or by technology. Water clocks and sundials in ancient times. Timekeeping by flow of water or position of the sun. Mechanical clocks. Clocks made with gears and springs for autonomous time display in medieval period. Early smart machines. Automated machines like Jacquard loom and steam engine in the age of Industrial Revolution. Electronic devices and computers. Electricity and computers enable automated elevators and calculators in the 20th century. Smart homes and robots. AI sensors, internet, and robots automate homes and devices in the modern times. AI-powered smart cities. AI manages city transport, health, and energy for automation and enhance efficiency in future. Page number 86. In this project, you will learn how to build similar systems using simple electronics and a microcontroller. You will observe how a tiny sensor can detect movement, how a computer chip can think and send commands, and how a light or a fan acts on those commands. By exploring automation, you will learn about electronics and programming, and how these ideas can be used in your homes and classrooms to save energy and improve comfort. Enjoy the journey into this exciting world of innovative technology. What will I be able to do? By the end of this project, you will be able to first, identify electronic components used in automation system. Second, read and draw electronic circuits. Third, design an automation system for a home or a school. Fourth, select appropriate sensors and program them. Fifth, install automation systems and test them. What will I need? Figure 4.3. Electrical and electronic components. In this figure, there are multiple pictures of different electrical and electronic components, starting with breadboard, microcontroller, LED, LCD display, buzzer, 9-volt battery, PCB, adapters, Arduino cable, jumper wires, DMM. Electrical and electronics components. First, breadboard. Metal strips inside the breadboard allow electronic components to be connected without soldering. This makes it possible to test circuits. Page number 87. Second, microcontroller. A microcontroller like Arduino Uno or Raspberry Pi can be programmed using a computer to control various devices like light-emitting diodes, LEDs, buzzers, motors, and sensors. Third, light-emitting diode, LED, a small electronic component that emits light when electricity passes through it. It has two legs. The longer one is positive, anode, and the shorter one is negative, cathode. Fourth, liquid crystal display, LCD display. It is a small screen that can display 16 characters per row and has 2 rows. Connected to Arduino with multiple wires. It is used to show messages, sensor readings, and data from an Arduino project. It requires a small potentiometer to adjust its brightness. Fifth, buzzer, a tiny electronic component that produces a sound when electricity flows through it. They are commonly used in alarms, timers, and notification systems. Sixth, battery, a portable power source that stores electrical energy and provides direct current, DC, power to circuits. Seventh, printed circuit boards, hard boards made of insulating material with thin copper tracks. These tracks connect different electronic components like resistors, LEDs, and microcontrollers, making a permanent circuit. Eighth, adapters, device that converts high voltage AC power from a wall socket into low voltage DC power that electronic devices like Arduino can use. It ensures a steady power supply and prevents damage to sensitive components. A common adapter for Arduino provides 9 volts or 12 volts DC output. Ninth, Arduino cables. They are used to connect an Arduino board to a PC. 10th, Jumper wires. Small insulated wire used to connect components on a breadboard or circuit without soldering. It helps transfer electricity from one point to another. 11th. Digital multimeter DMM. An electronic measuring tool used to check voltage, current, and resistance in electrical circuits. It is commonly used by engineers, electricians, and hobbyists to test and troubleshoot circuits. Page number 88. Figure 4.4. Sensors used in automation. In this figure, there are 3 pictures of different sensors that can be used in automation. The first one is of motion detection sensor. The second picture is of temperature sensor. The third picture is of sound sensor. Sensors. First, motion detection sensor. It senses infrared radiation, heat, from objects like humans and animals. When someone moves in front of it, the sensor detects the heat change and sends a signal to trigger an action. Second, sound sensor. It detects sound levels in the surrounding environment. It converts sound vibrations into electrical signals, which can be used to control devices like LED lights or buzzers. Third, temperature sensor. It measures the temperature of air, water, or any other surface. One popular type is the DTH11, which provides accurate temperature readings in degrees Celsius. Other material and tools. Soldering iron. Soldering metal and flux, multimeter, screwdriver, wire stripper, and laptop or computer. How do I keep myself and others safe? Some key precautions to be followed while working with electronics are as follows. First, safety from electrical gadgets. Avoid short circuits and check for loose connections. Second, soldering precautions. Use safety goggles, avoid inhaling fumes, and keep your hands away from the hot soldering iron. Third, handling tools. Use wire cutters and strippers carefully to prevent injuries. Fourth, workplace safety. Keep the workspace organized and free from unnecessary wires. Page number 89. Internet safety. Ask your teachers for help while using the internet. Be careful not to upload or download anything. And do not share personal information anywhere online. Important note: most of the home appliances use 230 volts AC supply. Electronics circuits we include in our activities work on DC supply. It would be dangerous to connect electronic circuits directly to AC mains. Only make circuits using DC batteries when you are a beginner. Figure 4.5. It is harmful to connect electronic circuits directly to the AC mains. There's a picture of a socket and a plug given here. It informs us that the circuits we are making in this project should not be directly plugged to the electrical sockets we have at home. It is highly dangerous. What do I need to know before I start? Before beginning this project, it will help if you remember some ideas from science. First, basic understanding of simple circuits. Second, simple circuit diagrams. Draw and read simple circuit diagrams and their components, as well as basic electronic components and their functions. Third, basic symbols used in electrical and electronic circuits are given here. Battery provides electrical energy. Resistance limits current flow. Earthing provides a safe path for excess current. Switch controls the circuit. Diode controls the circuit and direction of the current flow. LED, light emitting diode, used in lighting. Capacitor stores electrical energy temporarily. The scientific signs of all of these have been given in this picture. Before you start working on automation systems, explore the automation systems around you. Page number 90. Activity 1. Exploring automation in our surroundings. Look around your classroom, home, car, train, nearby marketplace, and community, or even in films and television. Look carefully for things that work automatically. Note your observation in Table 4.1. Table 4.1. Record observations for the automated systems. There are 5 columns and 5 rows in this table. The first row across all columns have been filled with examples for your better understanding. The heading of the first column, place or location. Example, refrigerator. The heading of the second column, what is automated? Example, cut off in case of voltage surge. The heading of the third column, what is happening? Example, if there is a voltage surge, the refrigerator gets switched off. The heading of the fourth column, how do you think it works? Example, a sensor detects a change in voltage. The heading of the fifth column, notes. Example, protects the refrigerator. Other 4 rows in this table are kept blank for your own observations. Reflect on your learnings. First, why do you think automation is required? Blank space is provided for your answer. Second, what excites you the most about the automated systems you observed? Blank space is provided for your answer. Page number 91. Third, brainstorm ideas you may have to make life easier and free of drudgery. For example, to help your parents or complete any laborious activities. Let your imagination run free. Blank space is provided for your answer. What do I have to do? Activity 2. Exploring circuits using a simulation platform. Have you ever played car racing games on a computer or mobile phone? If you have done that, then you were not driving a real car but a simulation. Do you know how pilots learn to fly a plane? Besides learning about aeroplanes and their functioning and flying with an instructor, they also use simulators. Simulators allow pilots to experience flying without actually being in a plane. Similarly, there are simulation platforms where you can try different electronic circuits without physically building them. You can draw circuits on a computer screen and test them to check if they work successfully. Simulation platforms help you prepare for building physical systems. In such cases, you will not be making mistakes when you make real-life circuits. In this activity, you will work on circuit simulation software to build and try out simple circuits. Box information. Tinkercad is a simulation platform. You can explore other platforms using the following search words. First, simulation for building circuits for beginners. Second, platform for making circuits. You can search for tutorials for simulations. For example, you can use the search keywords tutorial for making electronic circuit plus Tinkercad. Page number 92. Now, make a simulated circuit using the following components. First, LED 220 ohms resistor, DC battery 9 volts, switch. Second, buzzer 220 ohms resistor, DC battery 9 volts, switch. Follow the steps in figure 4.6 to make and test circuits. Figure 4.6. Using simulation to build and test circuits. There are different steps given in this figure with pictures related to every step for students' better understanding. Step 1. Draw the circuit you want to test. There is a picture given in which a student is trying to draw a circuit on a piece of a paper. Step 2. Open Tinkercad or any other simulation platform. There is a picture given of a screen in which Tinkercad's homepage is given. Step 3. Open Workplace and place the required components. There is a picture given with this step in which a computer screen is given. There is a picture given with this step of a computer screen in which a student is working in simulation on the website and trying to test his circuit design. Step 4. Make connections and test the circuit. There is a picture of a computer screen where the student is using Tinkercad and testing connections and circuit using simulation. Now, design a few circuits on your own and try them out. Answer the following questions based on the circuits you designed on the simulation platform. First, which software did you use? Blank space is provided for your answer. Second, Did your circuits work? Try different components such as other batteries and resistance values. Write your own observations of changes as a result of these trials. Blank space is provided for your answer. Page number 93. Third, draw the diagrams of the circuits you designed. Blank space provided for the student to draw the diagrams of the circuits that he or she has designed. Activity 3. Building circuits using physical components. You have tried out different circuits on the simulation platform. Now, build a circuit using physical components. Figure 4.6 has some suggestions. Figure 4.7. Creating electronic items with physical components. First, buzzer with battery and switch. There is a picture of a buzzer with battery and a switch. Second, 3-volt DC motor with solar panel. There is a picture of a 3-volt DC motor with a solar panel. Third, electronic rakhi. There is a picture of an electronic rakhi which has button cell which is attached to some LED bulbs. Fourth, dancing doll using LED and DC motor. There is a picture given of batteries that are connected to an LED and a DC motor. Page number 94. Box information. You can search for other circuits online using the following keywords. First, DIY circuits for beginners. Second, electronic projects for beginners. Reflect on your learnings. On the basis of the activity, answer the following questions. First, which circuit did you make? Blank space for your answer. Second, which components did you use? Write their specifications. Blank space for your answer. Third, draw circuit diagrams of the circuits you designed. Blank space for the drawing. Activity 4. Making the circuit smart. In the activities so far, circuits are controlled by a switch. You can turn a switch either on or off. This allows you to control the flow of electricity to operate the circuit, but you need to manage the switch manually. Page number 95. Now what if you want to make the circuit smart? You want your circuit to switch the circuit on when it is dark or switch the electric pump off when the tank is full. When it becomes dark at night, our eyes sense the darkness. Or when water starts overflowing from a tank, our ears hear that sound. Our sensing organs are the eyes, ears, tongue, nose, and skin. They inform our brains about things happening around us. Now, to inform an electronic circuit that it needs to become automatic, it needs to sense things. This is done by components called sensors. How automation works. When we touch something hot, our skin senses the temperature input. It sends a signal to our brain process. Our brain signals our hand to move away from the hot object. A representation of how one brain senses an input and processes it into output is given in Figure 4.8. Figure 4.8. Representation of how our brain senses an input and processes it into output. First, input. Skin senses temperature and informs brain. There is a picture given where a person is touching a hot pot. Second, processing. Brain processes the information and instructs hands to retract. There is a picture given of a human brain which senses the hotness by touching the hot pot. Third, output. Hand moves away from the hot object. There is a picture given here where the person immediately removes his hand from the hot pot. Similarly, automation follows a simple cycle that allows machines or systems to perform tasks without constant human control. This cycle consists of 3 key steps. First, input, sensing. Sensors detect changes in the surrounding, such as motion, temperature, or light. Example, a motion sensor detects movement in a room. Second, processing, decision making. A microcontroller or processor analyzes the input and decides what action to take. Example, if movement is detected, the processor turns the lights on. Page number 96. Third, output, action or execution. The system carries out the action based on the decision. Example, the lights turn on automatically whenever motion is detected. This cycle continues as long as the system is active, making automation an efficient way to reduce manual work and improve efficiency in daily life. The microcontroller is the brain of the circuit. Figure 4.8. It processes the sensor information and asks the output devices to act. You need to give instructions to get the desired response from the microcontrollers. Figure 4.9. This set of instructions given to the microcontroller is called a program. Figure 4.9. Microcontroller handles both input and output to make decisions. First, input. Sensing, sensors. Second, processing, decision making, microcontrollers. Third, output, action execution, output devices. These microcontrollers are like small computers. Depending on their processing power and functions, different types of microcontrollers are available in the market. You need to choose the microcontroller depending on your application. Figure 4.10 shows examples of microcontrollers that are commonly used by beginners. Arduino Uno and Raspberry Pi Pico. Figure 4.10. Figure 4.10. Arduino Uno A and Raspberry Pi B microcontrollers. A figure has a picture of a prototype of Arduino Uno. B has a picture of a prototype of Raspberry Pi microcontroller. Page number 97. Output devices. An output device is any piece of hardware item that takes commands from a microcontroller to perform specific tasks. Typical examples of output devices are LEDs, buzzers, DC motors, servo motors, stepper motors, relays, LCD, and speakers. Output devices can exist with or without sensor-like input devices. A person can operate the output device through a sensor or from the signal received from a microcontroller. Making simple circuits using microcontrollers. You learned about input devices, microcontrollers, and output devices. Now, let us connect them to make a smart circuit. You can use a breadboard to connect different components without soldering them. This will help you to test the circuit quickly. If something does not work, you can rearrange the parts. The breadboard is only for prototyping, a model used to test the circuit. Figure 4.11. Once your circuit is tested and working, you must solder the components and make the circuit permanent. Figure 4.11. A breadboard. There is a picture given in this figure of a breadboard. There is vertical grouping, that is, rows that are linked vertically on one side, and on the other side there is horizontal grouping where rows are linked horizontally. Microcontrollers. You can create an automation system using a microcontroller. Each microcontroller has a different number of pins. Each pin is for a specific purpose, such as connecting the power supply, ground, and input and output devices. Box information. You can search online using keyword understanding pin configuration of name of the microcontroller. Page number 98. Figure 4.12. Arduino Uno. Arduino Uno is shown in figure 4.12. There is a picture of a prototype of Arduino Uno. First, analog pins labeled A0 to A5 connect input or output devices such as parts like LEDs, sensors, and motors. Second, digital pins labeled 0 to 13 to give an on-off signal. They control LEDs, buzzers, motors, on-off signals, etc. Third, Universal Serial Bus USB port connects to a computer for programming. Fourth, power supply. A USB cable or a battery can power the microcontroller. Fifth, reset button restarts the program running on the board. Sixth, GND. GND stands for ground. It is a reference point of voltage in circuits and protects the circuit and the person working the circuit. You can try the following activities using microcontrollers, breadboards, and sensors. Box information. Glowing LED bulb using a microcontroller. For example, Arduino Uno. First, search for an online tutorial using the search keywords tutorial plus beginner plus microcontroller. Example, Arduino Uno. Second, connect the LED, battery, and Arduino pins with the help of your teacher. Download the Arduino IDE program from the official Arduino website. Third, start the Arduino IDE program on the computer. Go to File, then Examples, then Basics, then Blink. This will open a new window with the Blink program. Page number 99. Figure 4.13. LED off. There's a picture given in this figure in which Arduino board is used as a circuit and the LED light is off in this picture. Figure 4.14. LED on. There is a picture of an Arduino board circuit where the LED light is on. Fourth, now connect the Arduino board to the computer using its cable. Then open the Tools menu on the computer, go to the port and select Arduino Uno COM. COM number will be selected automatically by computer. Fifth, when done, click on the arrow under the File menu. This will upload the program to the Uno board. This should blink the Uno on-board LED every second. Sixth, now change the value in the delay command to set a different time for the on and off state of the LED and upload the program again. You can also try the following. First, on-off LED. Second, reduce or increase the blinking time of LED. Third, add multiple LEDs and blink them. Activity 5. Exploring automation cycle. Now, you know how to connect a microcontroller and program it using a computer. You also know how to give it power. Now, connect input and output devices to try the automation cycle. All automation processes have an input, a process, and an output. Figure 4.15. Figure 4.15. A. Some sensor modules. B. Microcontroller. And C. Motor toy. There are 3 different parts given in this figure with different pictures. A has different kinds of sensor modules. B has different prototype of microcontroller. C has different motor toys. Page number 100. What can be the input, process, and output for each digital device? One example for automatic street light is given here. Complete the details for water sprinkler and any device of your choice. automatic street light. Input: LDR, light sensor, senses light. Its resistance changes. It informs the microcontroller when light intensity drops. Process: microcontroller get a signal from LDR. It decides if it is getting dark from value of the input received. It instructs put light on. Output: light switches on with the instructions received from the microcontroller. Automatic water sprinkler system. There is blank space given here in 3 boxes for you to write your input, process, and output. An automation device of your choice. There is blank space provided in 3 different boxes for you to write your answers as input, then process, then output. Page number 101. Box information. You can search online for tutorials or circuits. You can use search keywords tutorial plus automated plus street light or your mobile or laptop plus your microcontroller, for example, Arduino. Now, make a small automation system using microcontrollers. Automation system. Smart light system using a microcontroller. Function. If some movement happens in the room, then the light will switch on. Microcontroller. Arduino Uno. Materials. The microcontroller Arduino Uno PIR motion sensor, 5mm LED, 220 ohm resistor, breadboard, jumper wires, USB cable, computer with Arduino IDE installed. Circuit diagram. There is blank space provided for you to draw your own circuit diagram. Process. Open the Arduino IDE and write or modify the code. Test the circuit. Automation system. There is blank space provided for you to write your response. Function. There is blank space provided for you to write your response. Microcontroller. Blank space provided for your own response. Circuit diagram. There is blank space provided for you to draw your own circuit diagram. Process. There is blank space provided for you to write your own response. Page number 102. Did your circuit work the first time? If not, please write down what you need to fix. There is blank space provided for you to write your answer. Activity 6. Make your own automation system using a microcontroller. You have learned about microcontrollers, their connections, and how they are connected with sensors and output devices. Use this knowledge and skills to make an automation system of your own. Box information. Following are examples of few automation systems. You can search for their tutorial online by putting them in the search words. First, instructions plus automatic plant watering system plus using Arduino, or any other microcontroller. Second, DIY plus automatic obstacle detecting system plus using Arduino or any other microcontroller. Third, DIY plus beginners plus automatic fire alarm system plus using Arduino or any other microcontroller. Fourth, DIY plus automatic plus gate opening system. Fifth, DIY plus automatic plus theft detection alarm system. Sixth, instruction plus smart fan plus or any microcontroller. If not exactly, then you can get program or instructions close to your application. You can take it as a reference and build on it to make program for your application. Page number 103. Reflect on your learnings. Question 1. What automation system do you want to make? What is the process? Blank space provided for you to write your answer. Question 2. Write about the input, process, and output of your project. Blank space is provided in 3 boxes for you to write your own answer as input, then process, then output. Question 3. What are the materials required by the automation system? Blank space is provided for you to write your answer. Question number 4. Did you modify the code received from other sources? Mention the site, the information you got, and the modification you made. Blank space is provided for you to write your answer. Page number 104. Draw the block diagram or sketch or circuit of your automation system. There is blank space provided for you to draw your diagram or sketch. Question number 6. Did your automation system work as per the plan? If not, what are the reasons? What will you change next time? There is blank space provided for you to write your answer. What did I learn from others? Question number 1. What are the precautions to be taken to protect the circuits from electricity fluctuations? Blank space is provided for you to write your answer. Page number 105. Question number 2. Did you take help from experts or peers? What are the 3 most important things you learned about home automation? Blank space is provided for you to write your answer. What did I do and how long did it take? It is important to understand how much time is required for an activity to be completed. Calculate the approximate number of hours you spent on each activity. Mark them on the timeline here. If you did more than the activity suggested in the book, please add the number and time taken. The first part is activity starting from 1st to 6th. The second part has time taken in periods and is kept blank for you to note your own responses. What else can I do? So far, you have provided power supply through a computer USB port to the Arduino board. But to make circuits independent of the computer, you need to package them with batteries or power adapters. Arduino boards take power from the laptop or computer. To deploy your system in the field, you need to package it with batteries. The Arduino board needs lithium-ion batteries. It also needs DC connector cables to connect the batteries to the Arduino board. You can make a casing using a 3D printer or use any other available materials to make a suitable casing. Page number 106. Think and answer. Question 1. Did you enjoy doing this project? Question 2. What did you like and what would you do differently next time? Question 3. Compare sensors and human sense organs. What can humans do with their senses that sensors cannot? What capabilities do humans have that automated systems do not? For example, can systems be designed to respond to human emotions? Question 4. Examples of jobs related to the work you did are automation engineer, technical support specialist, programmer, etc. What other jobs are related to the project? Look around, speak to people, and write your answer. Project 4 ends here.
Kaushal Bodh. You were just listening to this audiobook, Textbook of Vocational Education for Grade 8. Narration Himani Joshi. Sound recordist Mohammad Faizan Khan. Assistance in production Mukul Singh. Directed and produced by Vimalesh Chaudhary. This audiobook is brought to you by CIET NCERT, New Delhi, India.